We're studying IGCSE chemistry and we're starting metal revisions 2. Metals revision 2 is all about the uses of metals, the uses of alloys, what are alloys, how do we make alloys, and some questions on it. Let's see. So to recap first, Neha, recap, what did we do in the last class? Neha, recap. Anas, recap.
From last class?
Yes.
Okay. We learned about the physical properties and chemical properties of metals, non-metals, and reactions of metals, and the structure of metals.
All right. That's what we did in the last class, basically. Reactions, everything about basic metal stuff. Reactions, metals, structure, and property. And we looked at reactions of metals. Fine. Now today we're looking at alloys, uses of metals, the structure of alloys, and how do we identify these metals and stuff. Let's go back. Let's start. Let's first read from here. Ayan, read uses of aluminium metal. First, before you write uses, this right here is the property. So we're doing uses of metals. That's fine. Uses of metals. Right, that's what we're doing. But firstly, we'll write the properties of these guys. These are the properties. Properties of aluminium metal. Now, Ayan, read from here.
Properties of aluminium metal. It is strong, lightweight, it's a conductor of electricity, it has low density, it has less corrosion. It's used in airplane bodies because it's lightweight and strong. Overhead cables because it's low density and less corrosion, and foil for food because of less corrosion. And a bridge.
Okay, yep, that's it. So number 4 is also bridge. Why is it bridge? Because, well, it is strong and lightweight. I don't want my bridge to be heavy. Otherwise, it's going to fall. And everyone on, oh wait, that's not a good thing. Okay, we know what recently happened in India. There was a collapse of bridge, I think, in Gujarat, I think. That bridge collapsed.
I think that was a metal bridge.
There was, it was a metal bridge. I'm not sure, but well, that really gives us an insight on how important it is to use metals and proper metals for each use, right?
Yes.
Now, we haven't done this. We're doing it right now on us. So I want you to, everyone start writing from here. Now, we don't want accidents to happen, right? I don't want my bridge to be weak or it shouldn't cause harm to human lives or even animal lives, all kinds of lives. So we need to use the proper metals for its each use case. Now, the use case for aluminium is airplane bodies, overhead cables, aluminium foil for food, and also bridges. So start writing from here. Now I've given the reasons as well. Why is it used in aeroplane bodies? Because lightweight and strong. Why overhead cables? Because low density and corrosion, less corrosion. Why for food? Why? Because it's less corrosion again. For bridges, it's just going to be
Do we write
lightweight.
Aluminum?
Say that again.
What do we write as the
Yes,
title?
you'll start, yeah, the first thing you'll write is uses of metals as the heading today. And you'll write today's class, which is metals revision 2 and the date. Then you start by uses of metals and you'll start with, after that, that's the heading. And below it, you'll write number 1 properties of aluminium metal. Fine. And then below that, you'll write the uses. as the second heading. I hope that makes sense. Now, Neha, I want you to read this part one more time. The uses.
Okay. Yeah. Uses aeroplane bodies because lightweight and strong, overhead cables, low density and less corrosion, aluminium foil for food, less corrosion. And fourth one is bridge, lightweight, bridge, strong.
It's lightweight and strong. Now,
Yeah.
okay,
Right.
Neha, now you know all of this knowledge. I'm going to ask you a few questions. Fine.
Okay.
Now, can you tell me two properties of aluminium?
So
Two properties of aluminium.
two properties of aluminium. Okay. Um, 1 second. Let me think. Okay. So one is low density. I mean, wait, is it no? Yeah, low density.
Okay. And one more.
Uh, one more. Uh, 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 hmm, is it?
Right here. Let's read this one.
Okay, it's lightweight. Yeah, fine.
And this one.
Less
What is it?
corrosion.
Less corrosion. And it's also
All right. Yeah, strong. It's lightweight
strong.
and less corrosion.
Yep.
Fine.
All of these six properties are here. Now, Neha, I want you to read the sixth one. Forms
Forms. What is that word?
protective
Protective.
layers
Protective layer of
of
oxide to prevent rusting.
rusting. Now, let's write it properly. Just right here. Just a second. Okay. Now, everyone start writing. I want this in your notebook right now in 5 minutes, in 1 minute. Then we'll move on because there's lots of stuff remaining. Now, let's just write this quickly. I'll add a few things here. There's another point right here, which is number 6. 6 is forms an oxide layer that prevents rusting. Right? That's all you have to write. That's the sixth point, and it's very important, by the way. It's one of the, you may even say that that's the main thing. Lightweight is one of that. One of it, one of those main points of aluminium. Uh, Less corrosion is one of those points. And why is there less corrosion? Because it forms an oxide layer that prevents rusting. So we'll write that as well.
What does corrosion mean?
Yeah, exactly. That I was going to ask you that. What does corrosion mean? Well, corrosion, I'll show it to you, right? What better way than to show? Can you see this? What is this orange thing on this cool motorcycle? What is it? It is
Rusting.
rust. And rust has another name. It has a fancy name to it, which is corrosion. Now, corrosion, rust is mostly for iron. Okay, rust is for iron. But what about other metals, right? There are lots of metals out there. It's not just iron that is a metal. So we say rust for iron, but for everything else we say corrosion. But you need to realize that both these things mean the same thing. You can say rust or corrosion. It's the same thing, right? Doesn't make a difference. You can say rust for everything as well. So whenever they say corrosion, you should know that means rust. If they say rust, that means corrosion. Same thing. Now, Anas, does that answer your question?
Yep.
Okay. Now, next one. Finish writing, everyone, quickly.
Yeah,
There's nothing. Still writing. Now, I want you, let's say, Ritika, I want you to read the next one. Uses of copper metal.
The next one, use of copper metal.
Louder, I can't hear you.
Uses of copper. Okay, properties of copper metal.
Okay, yeah, go on.
Very high electrical conductivity, ductile, less reactive, and uses are electrical wiring, good conductor and ductile.
So it's ductile. What is the meaning of ductile? Is it like a duck? I don't think so, it's a duck. What does ductile mean? Ayan, tell me.
Able to like, can I?
Yes, Neha.
We can like, able to, it like we can convert it to a thin wire.
In wire.
Like we
Now, not
can,
this guy, right? Not this guy. So let's see right here. There's, I think it's given over here. Look, what is the meaning of ductile? Read this word out loud, Neha.
where is it?
This one.
Oh, okay.
Ductile.
Ductile, the ability to be drawn out into wires. Yeah, right.
Exactly. You said this exactly the same thing, right?
Okay,
Now
yeah, fine.
let's write one more thing. Now I need this in your notebook actually. Afterwards, not right now. We'll finish that first, and we'll write that afterwards. Now, what is the meaning of malleable, Neha? Read it.
So could you repeat?
Read this. Malleable. What is the meaning of that?
Oh,
Read it
malleable.
out loud.
The ability to be molded into shapes.
Ability to be molded into shapes, like a statue.
Shapes.
Yeah,
Yeah.
exactly. So if you can make a statue out of it, it's ductile. If you can't make a statue, it's going to be non-metal. That's how we see. But that's kind of quite a difficult way of judging if it's a
Sir.
metal.
If you are able to convert it into statues, it's malleable, not ductile.
No, I said metal. Okay.
No, before that you said that if it's like what did you say? If it's
I'll tell
able to
you. I'll
convert
tell you.
into statues, it is ductile.
No. That's not it. I'll tell you. If you can make it into statues, it's a metal. Okay.
Okay.
And if you cannot make it into statues, it has to be a non-metal. Now that's a very
Okay.
difficult way. That's a very difficult way of checking if it's a metal or non-metal, right?
Okay.
So
Okay.
we can't make things out of everything. We can't take a tree and make a statue and see if it becomes a statue. And some people can also make a statue out of trees. That's totally a thing. So there are a lot more properties of metals. Malleable is one thing. You can mold it into shapes. It's not trimming it, not cutting it. You have to mold it, melt it into some into lava kind of thing, and then put it into a container and then make the statue. That's what malleable means. You can do that with metal, like you can make coins and everything, right? But for
Yeah.
non-metals, if you melt it, they're going to burn. They don't melt; they directly burn. Now let's finish this. Properties of copper has been done, right? Finish writing, everyone. Finish writing, yeah.
I'm still on the uses for aluminum metal.
Aluminium metal.
Sir, I just joined back. What are we doing?
What are we doing? All right, let's recap. Now, what we did so far was properties of aluminium metal. What are they and everything? Airfin bodies and everything. And the reasons why they're used in such a way. Then we also looked at copper. Copper is it's a very good conductor of electricity, right? Very high electrical conductivity. It's one of the best. It's not the best, but it is one of the cheapest and one of the best. Now, it's also ductile, so you can make wires out of it. It's less reactive, so that's also good, right? We saw in last class how copper does not react with water, right? Not easily, at least. We saw only that reactive metals like group 1 alkali metals like sodium, potassium, they react with metals. On the other hand, these guys don't react that much. That's good. So how can I use it? How can I use copper? I can use it in electrical wiring because it's a good conductor and it's ductile. I can make wires out of it. That's what we've done so far. Now, your job is to finish writing the whole thing in your notebook. Right? Uses of metals, properties of aluminium metal, properties of copper metal, and then there will be uses. Now, Ritika, when you're done writing, tell me.
Yes, sir.
By the way, can someone tell me what is an overhead cable?
The cables that are over our head when we go outside, like hanging.
Okay. All right. Is it like a cable on your head, Anas?
No,
No, no, it is not. Okay. It's basically the
they're on the like streets, like
streets. Okay, okay,
when
okay.
to
I'll show it to you.
rod.
Okay, do one thing, write it, finish writing. You have to write the properties of zinc metal, properties of iron metal as well. Don't wait for me to tell you. Now I'll tell you what an overhead cable looks like. I'll show it to you, all right? A visual diagram. Now this is my drawing, right, for an overhead cable, but there's another drawing for it, which is this. Now if you look at this right here, this is your overhead cable. These wires are the overhead cable, not the pole itself, but not the rod, but the wires. Okay, I think you understand now. Let's go.
What does ductile mean?
What does ductile mean? We just did it on us. It is the ability to be formed into wires. Does that make sense?
No.
No? Well, not this guy. That's a duck. Okay? Not that guy. This guy, the one which we saw earlier. These are called wires, right? Can you see these wires on the screen, Anas?
Yeah.
Now,
No.
if you can make, now,
Yes.
yeah, if you can make an element into this wire, okay? If you can take a metal and you can make it into this wire, it is called ductile. Is that clear? So if you can
Okay.
make wire out of something, long wire, okay, then it is ductile. I'll give you the definition in a second. Finish writing everything. Uses of zinc metal as well. Neha, are you writing?
Do we write uses of zinc metal or properties?
Yeah.
We don't write uses, we write properties. Or the first ones are properties.
Okay, okay.
Okay. Neha, have you finished writing?
Sir, what?
Have you finished writing, Neha?
Yeah, I'm writing, sir.
Where are you right now?
Sir, I just finished with the properties of the copper metal. In the zinc metal part.
Now, the first thing is the property, then the use, right? Okay.
Yeah.
Now, Ritika, how much have you finished?
Sir, I just started the zinc metals. Can you like zoom in a little?
All right, I'll zoom in. Now, before we write it, Neha, I want you to read this part out loud.
Okay. Use of zinc metal. One, redox reaction takes place when galvanized to prevent rusting. Uses galvanizing covering with that's zinc, iron and steel to prevent corrosion.
So let's galvanizing. What is galvanizing? Galvanizing means to cover with something, all right?
Okay.
To cover. Now let's remove this from here. It basically means to cover. So the
Yeah.
use of zinc is to galvanize iron and steel to prevent corrosion. Corrosion is a big problem. It's a pain in our head. It's a headache.
Sir, one
Hard-
question.
Yes.
Why did you cut out the protective coating to corrosion?
That's aluminium. No, that's not zinc.
Oh, okay, okay.
That was
Sir, so what do we
aluminium.
write for zinc?
You write the first point, one property, one use. Fine. So the first one is the property, obviously. These are properties. And then you have one use for it, right?
Sir,
Write the
so it
property
prevents
first.
rusting?
No, the property is redox reaction takes place when galvanized to prevent rusting. And then the use is galvanizing iron and steel to prevent corrosion, right? Just write exactly that, what you have on the screen. You can also, yep, that's it. Write this. You don't have to put the red part on it. Only these lines. So first we write the property, which is that redox reaction takes place when galvanized to rusting. That's the property of zinc. That's one of the important properties of zinc. It's not for iron. Iron
Wait, can
does
you
not have
repeat
that property.
what galvanizing means? Because I wasn't able to hear you because I was
All right.
writing.
Galvanizing means to cover with something. All right.
Okay.
Cover with zinc. Now galvanizing means to cover with zinc. Is that clear?
Sir, isn't that electroplating?
Electroplating is different. In electroplating, you're depositing a whole layer, but here you're just covering it. Now we'll look at that afterwards. It's easy to understand it like this. But in this, galvanizing really means that, let's say you have this metal, a big block of metal, right? And on top of this, you put a zinc metal like this, a small piece of it. What will happen is this big metal, this big chunk of iron will not rust. In place of iron, zinc will rust. That's what galvanizing means. Now we'll look at that afterwards. Okay, it's not, we haven't gotten into it yet. So finish writing first, and I think it's right below this that we'll look at what galvanizing means. Okay, in a few seconds. Now, so finish writing this properties of zinc.
Sir, I'm done. Sir, I'm done with both properties
Zinc,
of
have you written? Iron.
Done, sir.
iron metal too.
All right. Ayan, finish with iron. Neha,
So,
have you finished iron as well? So
just
you
a
have to write
second.
the
I'm in
iron
the
one.
uses. 1 second.
Okay. Now, Ritika, read the properties of iron metal.
Properties of iron metal: hard, good conductor of heat, and uses are construction and utensils.
Utensils. That's amazing. Now, one thing you need to write is after construction, please write drill, because I remember that they ask this in the question a lot. So construction basically means drill. You can put this in a bracket like this in front of construction. Okay. Drill. What is a drill? Can someone tell me?
So like
The thing you use to make holes in the wall and disturb others.
Is it this? Is it this thing? Is this what you use to disturb others?
Yeah, that's drill, sir.
That's the drill, right? Disturb others. That's the device. Spot on. Now this is also a drill. Now, especially it's not the drill we're making. The drill also has plastic on it. It's especially the drill tip. Is that clear? The tip of the drill. Now, why would you ask me? Let's say you would ask me, why do we use iron as the drill tip?
Because
Just
it's
right.
a good conductor of heat, and when there is too much force added to a thing, it starts heating up.
No, but heating up is not good, right? If it heats
No.
up, then how will you make the hole if it melts? Now it doesn't melt. The thing is, it's very hard. You understand?
Yeah.
It's hard. It doesn't break. You can't make a hole and the trip will not break. It's very hard, and that's a good thing. So just write here drill tip, and because it's hard, like diamond. Now diamond is also used for drill tips, by the way. Okay, because they're very hard. They're not soft like zinc. Let's say if you push it, it's not going to bend easily. Like copper will bend easily, right? But iron will not bend. That's a good thing. Write this, tell me when you're done. And for utensils, the reason for utensils is that it is a good conductor of heat. Okay,
Done, sir.
so write the property after utensil as well. Why do we use it as a utensil? Because it is a good conductor of heat. Now, if you're cooking something, you don't want let's say this is what you're cooking, right? This is you're boiling water, and you want the temperature to go from the through the pan to the water very quickly. You don't want it to take so much time, and then you won't use wood because it won't heat up, obviously. Well, you won't even use aluminium. Best thing would be to use iron. It's also cheap, by the way. So good conductor is why we use it as utensils. It keeps our things hot. Any questions? Have you finished writing?
Yes, sir.
Okay, so that's kind of messy. Let's go somewhere else. Now, okay, look, we were talking about what galvanizing means, right? Let's see what galvanizing means. Look, if you have iron, what is this block called? This is a block of iron. Now, if on iron, if I blow air on iron, okay, and if I put some water on it as well, I'll put some water on it, H2O. Then what will happen, Neha? If you have air and water, what will happen to the iron?
Hello, sir. Yeah, it will rust.
Rust, okay, it will rust. Now, if I have, let's say, okay, it will rust. Now, let's see. What we realize is, if I put zinc on it, okay, now I have zinc on it, and that's fine. It's there just on top of iron. Now I'm also blowing air on it, and I'm also dropping water on it. It's in the rain outside, okay. First tell me, what is more reactive, zinc or iron?
Iron.
Iron.
Iron. Okay,
Yeah.
iron. That's what you think, but that's not the correct answer. Have I given you the reactivity series?
Wait.
No, sir.
No,
Now,
you
this is
didn't
the
give it, but
reactivity
we
series.
have it in a textbook.
Yes,
And
I'll
I
just write it
have a
here for you.
mnemonic for that. Zinc is, I guess, more reactive.
All right. So, kan kama zaf zaf kaf. That's it. That's your reactivity series. NaCaMgAlZnFeSn. That's tin, lead, copper, silver, gold, platinum. That's what we have. Now, if I look over here, the lower you go, the less reactive it becomes, or the higher you are, the more reactive you are. Is that clear? So higher is more reactive.
Yeah.
And what is higher in zinc or iron?
Zinc.
If zinc is more reactive, okay. Therefore, what does that mean? That means zinc is more likely to rust, right? More likely
Yeah.
to rust.
Yeah.
So if I put zinc on top of iron, then instead of iron, since zinc is more reactive,
Zinc
it
would
will rust
rust.
first.
Yeah.
It will rust first, okay? It's not like iron will not rust, but zinc will rust first. And when the zinc is used up, all of the zinc has rusted, then iron will rust, okay? That takes some
Yeah.
time. So that is good. So we'll have to replace the zinc after some time. We'll have to put a new block of zinc on top of it. But it will prevent the iron from rusting. So we are happy. I hope that makes sense. Now we look at this in rust prevention. So I'm not asking you to write anything right now. A few things I would ask you to write is, please write this down. Actually, no, don't write that. Never mind. Let's go right here. Now, everything is done right there, right? Any questions, anyone? Ritika, any questions? Ritika, any
No, sir.
Sir,
questions?
no, sir.
No.
Would we write
Now,
after
iron.
properties of iron metal and uses?
Yes, what do you write? You read it first. So Anas, start reading. Everyone start writing alloys, and then the example of alloys.
Okay.
Okay.
Alloys,
Now,
a mixture of two or more elements, usually metals, but also with non-metals.
Okay, you don't have to write this. Stop. We have to change it a bit, just a little bit. Mixture of a metal with other elements. With, let's say, other elements. That's the definition in your syllabus booklet. That's much better. Now you can write the previous one as well, but this is an improved definition, which is from the marking scheme basically. So finish writing. A mixture of a metal with other elements, usually metal with metals, but also non-metals can be added, right? So let's say I have copper and I add zinc with it, and I'll get this mixture, this new block which has both copper and iron. Okay, and I'll add some other stuff as well. I'll add, let's say, nickel as well. And ta-da, I have bronze. See how easily I can get bronze by just adding a few metals together. And bronze is very good. It doesn't react at all. It's very strong. So that's how we get alloys. Write the definition, and then we look at the examples of these guys as well. So start. Now, actually, Neha, I want you to read the definition of alloys one more time.
So,
The definition of alloys one more time.
Yeah, okay. Alloys, a mixture of a metal with other elements, usually metals, but also with non-metals, provide improved qualities.
So to provide improved qualities, that's basically why we make alloys. I hope that's clear. Now, let's see. Uh, Next thing we have to read is, now Neha starts writing, and Shrey here, Shrey is not here, right? He doesn't have internet. So next one is Ritika. Ritika starts reading. Ritika,
So did you call me?
yes, read. Start from there.
Examples of alloys.
Yeah,
Uh,
examples of alloys.
Brass, copper, and zinc. Copper is 70% and zinc is 30%. Properties of brass: stronger, more resistant to corrosion. Uses of brass: electrical fitting and car rad- radiator.
Radiator. Car radiator is basically
The example
uh
of alloys and
yes,
alloys.
yes,
Oh,
these are the examples of alloys, right? They have to keep writing the whole thing. Up till stainless steel. Now the next one is iron. Read bronze.
Bronze, copper, and tin. Properties of bronze are stronger, harder, and sonorous. It's used in coin statues and springs.
All right, it's used in coins, statues, and springs. That's the use of bronze. It's also used in medals, right? Okay. Mm, Next one. Neha, read.
Yeah.
writing the definition for alloys.
The definition is a mixture of a metal with other elements. Now, Neha, read
Yeah.
stainless
Where
steel.
was he? Where did he stop?
Stainless steel.
Yeah. 1 second. Yeah. Stainless steel, iron, chromium, and nickel properties does not rust.
It does not rust. And uses are
And the uses are cutlery, kitchen sinks, and what is that? Um,
surgical,
surgical instruments. Sorry, I couldn't say it. Yeah.
surgical instruments. Now, look, if how do you feel if you go to a clinic, and let's say you go to the NHS, or in India you go to some any hospital, and they have, let's say they're going to give you an injection, all right, and that tip has rust on it. Now that would basically be very harmful to your health. Why? Because rust is poisonous, by the way. If it gets in your blood, it is going to make a very big, let's say, harm to your health. That is why we need our surgical equipments to be rust free. You don't want rust in your blood. That's all I can say, right? So we use stainless steel to make surgical equipments, cutlery as well. I don't want to eat rust. That's not good. That's all the things. Now, one more thing is these questions are asked in the MCQ. Lots of these questions are asked in the MCQ. So you have to memorize the percentage as well, 70%, 30%. They'll ask you this. They'll tell you what is the percentage of zinc in brass. You'll have options like 1%, 5%, 80%, 30%. And you'll have to choose 30% there. Okay.
So what about bronze?
Bronze, yeah, that's what I was thinking. So I'm going to give you the percentage in a second. Finish writing. Just give me a few minutes to remember it. All right. By the way, what is corrosion? What is rust? Rust is iron oxide. It is called Fe2O3. That's iron oxide. Now there's a big chapter on this. After we finish the uses, we look at rust prevention. How can I prevent rust? All right. And there we will look at all of these things, such as we'll focus on rust a lot more. Right now, we don't care about that. We just care about the alloys, their uses, and their properties. So next, and tell me when you're done. Now for bronze, bronze, right? You asked me that. Anas, not Ayan asked me. So copper is 90%. You'll have to check once, but copper is 90%, and tin is 10%. I don't think you have to check. It's correct. Okay, write this. 10, 90%, 10%. But the thing is, they won't ask you about this. They won't ask you about drones. They will only ask you mostly about stainless steel. So this is important, especially stainless steel. Now we have another alloy. Please write it down after this. We have three. There's fourth one, which I don't think I've given here. Right over here. The fourth one is called mild steel. This is in another chapter of extraction of iron, but we'll do this here as well. Mild steel. Now, mild steel is basically iron and carbon. What is the use of this, or what are the properties? The properties are, first thing is, it is hard. Let's just say stronger and harder. So where is this useful? This is useful for car bodies. And you'll be shocked to realize in how many marking schemes the word car bodies appears. Okay, it's always there. So mild steel is car bodies. Yep, that's it. It's stronger and harder than pure iron. Finish quickly. We don't have time on that. A lot of time, so hurry up. Now there's also been lots of changes to your syllabus. Okay, I'm closely focusing on checking the syllabus constantly to make sure that you're learning only the things which are coming in the exam. Fine, you should do the same. Check the syllabus booklet. It should be in the GCRs. Open it, check which topics are there, which topics are not there. Or you can also trust me to do that for you, because I'm looking at it. I am providing you only the topics which are there. So let's hurry up and finish, right? That mild steel has, write the percentage of this as well. Iron is 99.7% and carbon is 0.3%. Now you may say that's nothing. That's just that's rookie numbers, right? Do less, but not really. That 0.3% carbon makes a huge difference. You will see why in a second. Any questions, Ritika, Neha?
No, sir.
Anas, what are you writing right now? How much have you finished?
I'm on bronze. I'm writing the properties of bronze.
Bronze. Write quicker. In the exam, you'll have to be much faster than this in writing, especially.
Sure, I'm done.
You're done. Okay, Ayan, that's good. Ritika,
Sir, I'm writing the mild steel.
that's good. In the exam, you should have, so look, you'll have a paper of 1 hour. Okay. Now, in that 1 hour, you have to leave 15 minutes for, let's say, cross-checking or proofreading things. So you only get 45 minutes to solve the paper. The 15 minutes, as per the examiners, is extra. You don't need that extra 15 minutes to solve the paper. It's there for you to cross-check your answers. Okay, is there anything missing? No, that's it. As soon as you're done, we'll move on. We'll look at the structure of alloys. We've looked at the structure of metals. That's fine. But what about the structures of alloys? We'll do that after this.
Sir, I'm done.
Done. Neha, how much have you finished?
Sir, the mild steel, stronger and harder than Amata.
Okay. Now for the other people, I'm going to take a quiz. All right. It's like a points thing. It's a competition like basketball, like badminton or tennis. You have a few people, Anas, Ayan, so ANAY.
Sir,
Uh,
actually, I gotta
yeah.
leave because I have another tuition. So,
Now you'll have to stay for at least 10 more minutes, all right? Because we have one more topic we need to cover. So finish writing quickly now.
I know, but like my the other sir is waiting. So, like, what do I do?
You just ask him to wait a little bit more because this is an important class, all right? Otherwise, I would let you go. Fine. So finish writing. We're waiting. We're waiting for you, Neha.
Yeah, I'm done. Sir.
Done. Then let's go. Let's write. Look at this now. It's very important. Now for the Ayan, quickly check. Have you done the properties of the structure of metals and why they're conductors? Check. Tell me. And Neha, start reading from here. We have done structure of metals. That's done.
Yeah.
So I've done the physical and chemical properties.
What? Okay. Have you done why they are conductors?
No.
No.
No. No. Are you sure? Okay. Let's go back to it then. Okay. Just a second. We have to show it to you. Now, can you see the whiteboard?
No, sir.
No, sir.
Yeah, now we can.
Right now.
Okay. Quickly finish writing this. Quickly. Start over here. Structure of metals. Write the structure of metals. Write the question below it. Why are metals good conductors? Why are metals malleable? Quick. Or before you write that, I think you have done this before, the structure of metals. Please just write this part. So write structure of metal and then write these questions. Quick, hurry up, tell me when you're done. Neha, have you finished writing this?
Yeah.
Okay, just a second. Now, one last thing.
Yeah, I'm still on stainless steel.
Stainless steel. So Anas, write the structure of metals first. We'll go back there afterwards. Okay, you can stay after class for a few seconds. So structure of alloys, write this quickly. All you have to write is make one thing, the diagram first. Make the diagram like this.
Done, sir.
Write structures of alloys now. Structure of alloys, and make the diagram which looks like this. Or let's say something which looks like this. Yep. And when you're done making that, tell me when. Tell me. Okay. And then the last thing you have to write is why are metals, why are alloys harder than metals? The answer is layers cannot slide over each other easily, as in pure metals. That's it. Now, as soon as you're done, you can leave. Now, one thing, Neha, can you see this on the board?
Yeah.
Now, if you compare this guy, let's look at this. Finish writing quickly as well. If you look at the first one, the metal, you'll realize they have a lattice. They have an ordered structure. And can I
Yeah.
slide them like this? I can slide them, right? But if
Oh,
I do
yeah.
the same thing for these guys, look, can they slide?
No, because like they're not in a proper lattice structure.
No, they have different sizes of
Yeah,
atoms.
different
Okay?
sizes, right? Yeah.
So exactly, uh, layers cannot slide over each other as easily, as easily as in pure metals because of different sizes of atoms. That's it, and we're done. So Anas finished writing as well. Neha finished writing. This structure is guaranteed to
Sir,
be asked in the.
I'm
Yes.
done writing. Can I leave?
Yes, now you can. All right, finish writing. Then take
Yeah.
care. Goodbye.
Thank you so much.
Now, the rest of you can hear me. Ritika, how much have you written?
Yes, sir, I can hear you.
Have you finished structure of alloys?
Yes, sir.
Now, let's just see. We'll do this one more time. The only reason alloys are harder than metal. Now, what is the meaning of being hard? That they do not bend easily. What is the meaning of being hard, Ritika, or of a metal being hard?
So that like it cannot be bent or broken easily.
Easily. So, if what does the bending part mean? If I can cause the layers to slide, that's technically I'm bending it, right? So if I can slide these layers, it is bending.
Yes, sir.
It can slide. But on the other hand, if I have, let's make a better drawing of this, let's say. On the other hand, if I have these atoms right here, okay, these are my atoms. Now, what's happening is really that I have another atom which is quite bigger than the others, like this, and it's stuck right here, like this. So we have a mixture of these big atoms with small atoms. And what they do is this prevent the sliding from happening. So if I see right here, let's say, if I look at this layer, can it slide or is it blocked?
Log.
That can't slide. If I look at this layer, the below one, that can't slide either. It literally can't go anywhere. So that is why it's harder because the different sizes of atoms. Okay.
So if they can flow, if
Yes.
they can flow easily, they're like not hard. And then if they cannot flow, like if they're packed or something, it's harder.
Yes, it's harder. So the reason is they cannot slide. The word is slide. That's the golden word here. All right. So if you write cannot slide, just that, nothing else, you'll get the mark in the exam. That's how the IGCSE system works. Fine.
Okay.
Now, have you finished writing? Ayan, have you finished? Ayan, any questions?
Yeah, done, sir. No questions.
Okay. Anas left. Oh wait, you have okay. So that's all for now. I'll tell you what we're doing in the next class. The next class we're looking at, or quickly, Ritika, recap what did we do in this class?
Sir, today we did about the properties of different metals, like aluminium, and copper and bronze.
Louder, speak a bit louder.
So we did the properties of metal,
Okay.
and we also did about alloy, and then the structure of metal and structure of alloy.
All right, that's it. Now we have reactivity of metals in the next class, and we have extraction in the next class. Now that's all for now. All right, take care. Goodbye.
Goodbye, sir. Thank you.